Hello students, let us see the problems based on covalent coordinate bonds and VBT. The first question is, the bonds present in N2O5 are, the options they have given are related to ionic covalent coordinate type of bond. So let us first check the structure of N2O5. So the structure of N2O5 is NON, that is a peroxide linkage, attached to double bonded oxygens in this way and a single bonded oxygen like this. If you see this oxygen, there are three lone pairs each on the two oxygens in this way, and therefore there is a possibility that nitrogen forms a coordinate bond also with this oxygen in this way, and therefore students, what you see here, they are covalent and coordinate bonds. So answer here is second option. Let's see the next question. Which of the following model best describes the bonding within a layer of the graphite structure? To know the type of bonding, let us first see the structure of graphite. Now if you see the structure, graphite looks something like this. They are the carbon to carbon bonded sheets, and every sheet is bonded to the other sheet. Now students, if you see the type of bond between a carbon to a carbon, this is a covalent bond, while between the sheets, that is this to this or this to this is a van der Waals interaction, which is very weak, and because of this the two sheets, they can slide on each other, and so graphite is used as a lubricant. Now here what they are asking is within a layer of the graphite layer. So if it is within the layer, then it is a covalent bond, and if it is between the layers, then it would be van der Waals. But as the question demands, it is within a layer, so within a layer it is a covalent bond. Next question is, so NH3 and BF3 combine readily because of the formation of, let us see the structure of ammonia. Ammonia is nitrogen attached to three hydrogen, and there is a lone pair here, means this is a electron rich molecule. If you see BF3, then BF3 structure is like this, BF3. As the three fluoride atoms, they are strongly electron withdrawing. Here boron becomes electron deficient, and therefore this electron rich nitrogen can donate or coordinate a bond with BF3 because boron being electron deficient, and so the bond between them that exists is a coordinate bond. So the answer here is third option, which cannot be explained by VBT. VBT limitation was that it could not explain the paramagnetic nature of oxygen, which was further explained by molecular orbital theory, and so here the answer is third option. See the next question. Which of the following leads to bonding? Now students, always remember, for a bonding there should be an overlap along the internuclear axis. Now if you see this is a s orbital, this is a p orbital. Now if they overlap, the p orbital must be along the x axis, so that it will be having a internuclear overlap. So this is along the y axis, so there won't be any overlap here. If you see the same here, this is what is given here is the p to p orbital, and this will give you, this is having a negative charge here. If you see this will, of course there will be an overlap, but it will give a pi bond. And if you see this also, this will give you a pi bond. So what is the correct option here is, the correct option for this question is B option, because here it is along the internuclear axis. If you see the type of bond that will be formed, so the bond will be formed in this fashion along the internuclear axis, and so this what will get you is a sigma bond due to the PP overlap, but the overlap is along the internuclear axis. So the answer here is B option. See the next one. The molecules which has zero dipole moment is. To check where the dipole moment will be zero, you need to draw the structures. So let us draw the structure for the first molecule. The first molecule is CH2Cl2. So if I draw the structure will be CH, H, Cl and Cl. You know students that Cl is an electron withdrawing group, while hydrogen is an electron donating group. So its flow of the electron will be in this way for this, and in this direction for this, while this being an electron withdrawer, the flow will be in this way, and therefore the flow of the electron, the dipole, will be in this way and this way, and therefore it shows a dipole of nearly 1.6 dBi. So there is some dipole in this molecule. Let us see the second option, that is BF3. If you see the structure of BF3, here it is undergoing sp2 hybridization. So the geometry of the molecule will be in this manner. So you know all three fluorines are there and they are electron withdrawing groups. So this will have in this fashion, while this will have in this way. If you see the resultant dipole here, so the resultant dipole will be in this way, which is nullified, and therefore the net dipole here is 0. So the answer may be BF3. Let us check the remaining molecules also. NF3, here nitrogen is undergoing sp3 hybridization with one lone pair. So what will be the structure, student? Nitrogen and 3 fluorine like this. Fluorine being electronegative, it will pull the shared pair of electron towards itself. So the pull will be in this way, but the lone pair will pull this in this direction, and there will be a small dipole moment which is nearly 0.24 dBi. If you see the next molecule, that is ClO2, let us check the structure. ClO2 will have a structure of Cl double bonded oxygens in this way, and it will have 2 lone pairs in this manner. So students, you know oxygen is also electronegative, so it will have a pull in this direction, while the lone pairs will have pull in this direction. So the pull of the lone pair is of course more, and it will show a dipole of nearly 1.79 dBi. So the molecule which is showing 0 dipole is BF3. So your answer is second option. Let's see the next question. How many covalent and how many coordinate bonds are present in Al2Cl6? If you see Al2Cl6, aluminium is electropositive while chlorine is electronegative, and therefore chlorine will pull the electron clouds towards itself, making aluminium electron deficient. Now how the structure is balancing this electron deficiency, and therefore it is existing in the dimer form. So let us see the structure of this. So the structure will be Al, Cl, Cl and Cl. The other molecule like Al, it will have Al in this way. So the 3Cl. Now if you see the structure here, aluminium is electron deficient, and to fulfill that condition, there will be a coordinate bond from this Cl to this aluminium, and the same coordinate bond will be seen in this direction. So the Al2Cl6 will have this type of structure. Now students, so how many covalent bonds are there? 1, 2, 3, 4, 5 and 6. So there are 6 covalent bonds and 2 coordinate bonds. So the answer here is first option. Let's see the next question. Identify the correct sequence of increasing number of pi bonds in the given structures. To know that, you must know the structures of the molecules. So let's first see the structures. The first acid they have given is H2S2O6. So how you will draw the structure for this? The structure for this will be S, double bond O here both on the sulfur atoms, and OH on both the sides. So how many pi bonds are there? Here you have 4 pi bonds. Right students? Let us see the next molecule, that is H2S2O3. H2S2O3, this is thiosulfuric acid, and therefore it will have a sulfur to sulfur double bond. So the structure here will be S, double bond S, double bonded oxygen and 2 OH attached to it. So this is the structure. So there are 2 pi bonds in this molecule. Let us see the third one, that is H2S2O5. So H2S2O5, let us draw the structure for this. This will be sulfur to sulfur, double bonded oxygen on both the sulfurs, OH on both the sulfurs, and you have double bonded oxygen. If you see, there are 3 pi bonds here. So let us arrange them in the increasing order. So increasing order will be, this will be your first, this will be your second with 3 pi bonds, and this will be your third with 4 pi bonds. And so the answer here will be, first it will be third option, that is first, second, then you have third, and then you have first. So answer here is third option. Let's see the next one. Question number 17. Which of the following ions does not have SS linkages? Now students, they have given all the 4 options. So let us draw the structure for all the 4 ions. So if you see the structures are in this way. For S2O8 2 bidas, the structure is this. S2O6 2 bidas, structure is this, and for the S2O5 2 bidas and S2O3 2 bidas, the structures are like this. Students, if you are interested to know how to draw the structures by using some tricks, then please do write in the comments so that I can take one video only on how to draw the oxo acids of sulfur and phosphorus. So those are the structures. Now the question is, which of the following ions does not have SS linkage? So all the 3, they have the SS linkages. You can see here, this is the SS linkage, this is the SS linkage. Here the answer here is first option, that is Marshall's acid, where there is no SS linkage. So the answer here is first option. Let's see the next question. Which of the following statement is correct for carbon monoxide? So let us see the structure of carbon monoxide first. Carbon monoxide structure is C double bond oxygen in this way. I can draw this as, let us start with the first structure, that is, if I draw the initial structure of this skeleton in this way, so I will have this. Now there will be a resonance, so what I will get is carbon double bonded oxygen with 2 lone pairs in this way. Now again this will come to this side, you will get C triple bond oxygen and lone pairs in this way. You can draw this directly, the structure here. Now students, you know that here if you see the carbon, which is 1, 2, 3, 4, 5 and 6, there are only 6 electrons on this, and therefore this is not stable, and so this electron rich oxygen prefers giving 1 electron pair through coordinate bond. So 1 will be of the coordinate nature. So the structure for this CO2 will be something like this, that is triple bond oxygen and a coordinate bond. So the answer here is, let us check the options. So the options are a double bond between carbon and oxygen, 1 sigma, 1 pi, 1 coordinate bond between carbon and oxygen, 1 lone pair of electron on each carbon atom, 1 sigma, 2 pi bonds between carbon and oxygen. If you see the structure, there are 2 covalent bond, one is sigma, one is pi, and a coordinate bond. So the answer here is second option. 1 sigma, 1 pi and 1 coordinate bond between carbon and oxygen. Students, if you find this video useful, please do share with your friends. Thank you students for watching.